Why do most rotating storms fail to produce tornadoes, while a rare few unleash such catastrophic fury? In the heart of the storm, nature plays a riddle, a puzzle that challenges our deepest scientific understanding. Today, we embark on an exploration into the hidden minutes before a tornado's touchdown, a fleeting moment when the atmosphere whispers its secrets in microprocesses too delicate for even the most advanced instruments. This is the unsolved mystery of tornado formation. Our journey begins with a simple yet confounding observation. Nearly 90% of rotating supercells never produce a tornado. Behind that statistic lies an array of questions. What is the missing element that transforms a swirling mass of clouds and wind into a violent, twisting funnel? In the final 5 minutes before a tornado strikes, the delicate balance of nature is disrupted by subtle shifts in the boundary layer and minute atmospheric changes. It is in these critical moments that scientists struggle to capture the full picture. A picture that, despite decades of research and advanced technology, continues to evade precise measurement. As storm systems churn all around us, we are forced to confront the limits of our knowledge. The instruments that have long served as our eyes into the tempest prove inadequate when faced with the scale of nature's clockwork. Doppler radar, for instance, is remarkably effective in tracking large-scale storm dynamics, yet even it cannot fully resolve the micro-scale processes that tip the balance in the final moments before tornado formation occur. This challenge of measuring the ephemeral dynamics at the heart of a storm is nothing short of monumental. Probes and drones are deployed into the very eye of danger, teetering on the brink of the unknown as they attempt to record rapid changes in pressure within the turbulent vortex. The information they gather is incremental, piecemeal, a collection of clues that, when pieced together, may eventually reveal the elusive processes that drive tornado formation. Yet each foray into the storm's core is accompanied by a level of risk that is as daunting as the mysteries the instruments seek to decode. To further complicate matters, our current benchmark for understanding tornado intensity, the enhanced Fujita EF scale, is based on damage assessments made after the storm has passed. This approach, while useful for damage classification, falls short when it comes to providing a real-time understanding of a tornado's true energy and formation. How can we truly comprehend the ferocity of a tornado if we only see its effects in hindsight? The EF scale offers a glimpse into the aftermath, but it leaves a critical gap in our immediate grasp of nature's most unpredictable phenomena. In our quest for answers, we follow a band of intrepid storm chasers, the modern-day explorers of nature's fury. These scientists and meteorologists, driven by both the allure of discovery and the urgency of improving public safety, risk life and limb to gather critical data that might unlock the secrets of tornado formation. Taking us deep into the realm of advanced technology, they utilize phased array radar systems and cutting-edge computational models in an effort to capture every nuance of atmospheric behavior. Their work is at the forefront of meteorological research, MOG, and their stories are woven into the fabric of our understanding of severe weather. Imagine a day when you can stand on the open plains, watching the sky darken in an almost tangible sense of foreboding. The horizon is filled with the swirling menace of clouds, and as you witness the subtle curl of a developing storm, you are reminded of nature's dual capacity for beauty and terror. For these storm chasers, each mission is a race against time, where every second is a gamble, a moment when the atmosphere may either confirm long-held theories or defy them entirely. With sensors calibrated to the finest detail and every eye focused on the volatile skies, their instruments capture data that speaks of rapid pressure drops, swirling winds, and temperature shifts, each a piece in the puzzle of tornado formation. But the story of the tornado is not merely one of scientific inquiry and technological innovation. It is also intrinsically human. Survivor testimonies weave a tapestry of experience, each narrative marked by near-miraculous escapes and profound losses. In the aftermath of these devastating events, accounts emerge that chronicle the astonishing speed and unpredictability of the phenomenon. People recall moments when there was barely time to react, a flash, a roar, and then silence after the storm had passed. These final, harrowing experiences serve as a reminder that our current methods of warning and classification, while continually improving, are still falling short of fully capturing the nuanced terror of a tornado's onset. In one such account, a survivor described the experience as encountering an almost supernatural force of nature, a violent gust that seemed to exist in a realm between chaos and order, a force that defied prediction. These personal stories underscore a profound truth, that even as we push the boundaries of scientific measurement, the human experience remains at the very core of this mystery. The interplay between human vulnerability and natural might adds an emotional layer to our quest for understanding, a layer that is as urgent as it is heartbreaking. Each story is a testament to the primal fear and awe that tornadoes inspire, fueling the relentless drive among scientists to decode the exact moment when potential turns into catastrophe. As research advances, every increment of new data brings us one step closer to unraveling the complexities of tornado formation. Yet, with every answer, new questions emerge. How can we refine our tools to capture the micro-scale atmospheric changes that occur in mere minutes? Is it possible to deploy even more sensitive instruments into the storm's core without jeopardizing the lives of those who brave such frontiers? And perhaps most hauntingly, can we ever fully predict the circumstances in which a benign rotating storm spirals into a life-threatening tornado? The quest to solve these questions is not simply an academic pursuit. It has profound implications for public safety and emergency preparedness. Every breakthrough in understanding atmospheric microprocesses could lead to earlier, more accurate warnings, potentially saving lives and reducing the destruction wrought by catastrophic storms. In the laboratories, scientists pore over data collected from daring field experiments and from the aftermath of past storms. They sift through mountains of information, looking for patterns hidden in the chaos of meteorological phenomena. Computer models simulate the conditions that might trigger a tornado, exploring scenarios that blend atmospheric pressure dynamics, temperature anomalies, and wind shear. Every simulation offers a glimpse into the realm of possibility, a possibility that may redefine our understanding of weather forecasting in the years to come. Yet, as we delve deeper into the intricacies of the storm, the complexity of our task becomes increasingly apparent. The atmosphere is an endless ocean of variables, and the slightest change in any one factor can have sweeping consequences for the overall behavior of a storm. What seems like a negligible fluctuation in pressure or wind speed can be the decisive factor that alters the course of a supercell entirely. It is this unpredictability that continues to confound even the most sophisticated models, leaving us with more questions than answers. Amidst this intricate dance between theory and observation, the human element remains a vital thread. Storm chasers are not merely data collectors. They are witnesses to nature's raw power, each episode reinforcing the need for a deeper commitment to understanding and preparedness. Their courageous exploits inject a sense of immediacy and realism into scientific research, reminding us that behind every data point lies a real risk, and behind every theoretical breakthrough lies the promise of saving lives. In reflecting on our journey through the eye of the storm, we arrive at a profound realization. The mystery of tornadogenesis is emblematic of the broader challenges that science faces in grappling with the unknown. For centuries, civilization has sought to tame nature through understanding, only to discover that the more we learn, the more we recognize how much remains hidden. At the intersection of technology, human courage, and scientific inquiry lies the enduring drive to push beyond our current limits, a drive that propels us into the storm and compels us to ask yet again, why do most rotating storms fail while others unleash catastrophic force? Now, as we stand on the brink of deeper understanding, our journey serves as a call to action. The exploration of these final, critical minutes before a tornado's touchdown is not just a technical challenge. It is a quest that touches upon our inherent need to safeguard life and comprehend the overwhelming power of our planet. The data, the daring experiments, and the personal stories all converge to form a resounding plea for continuous research and innovation. Every new theory, every daring field mission, and every meticulous measurement is a step towards a future where we can better predict, understand, and ultimately live with the unpredictable nature of the vortex. This documentary is an invitation to join that future, a future where the veil of mystery over tornado formation is slowly lifted through the relentless efforts of scientists and storm chasers alike. A future where the unpredictable nature of tornadoes is not just a source of awe and fear, but a challenge that brings us together in our shared quest for truth. Join us as we delve into the enigma of tornado formation, exploring the unseen processes that challenge our current meteorological understanding and the brave individuals striving to uncover the truth.